Okay, good day everyone. All right, you are welcome back. Now, we are continuing with the buck boost. So let's look at the waveforms. And we said in the previous video, when this is on, you have this equivalent circuit. And when this is off, you have this equivalent circuit. So the first thing is, let's now look at the voltage. We're going to look at the voltage across this at time of on and time of off. Voltage across the inductor. Okay, that's the first waveform we're looking at here. Voltage across in time of inductor. At time of on, you know, remember that T on is KT. So between here and there is a time on, right? KT. And at time of on, Vs equal to VL. All right, so that means VL here is a positive value. This will be Vs, all right, at time of on. VL, this is the axis for VL, right? So we'll have Vs. And then at time of off, VL is minus VO. So I'm going to put down here minus VO. All right. Now, once we're done with that, let's now look at the nature of the current flowing through that inductor. Okay, that is your IL. Now, if you check here, at time of on, current builds up. So current builds up. And then at time of off, whatever that you have here, discharges to the load. All right, goes here and some will go there. All right, so current, in other words, the current here goes down. All right, so it falls. So you get like that. It will be going up, down, up, down. So you can get the average value of that. All right, remember the average value has to deal with what is going in here. This is where the current that flows through here at time of on and time of off depends on the switch. So if I know the I in current flowing from here, all right, you divide it by the duty cycle, okay, the switching on and off. So here the average value, I average, will give you I in over K over the duty cycle. All right, that will be the average value of this ripple. And then remember that between this and that is your peak to peak ripple current on the inductor. All right, so you have that like that. Okay, so you're going that way. Okay, now let's look at the current flowing through this transistor. Let's look at it. Look at it. If you switch this on, the current flowing through the inductor is the same thing. All right, so that means this one is the same thing. So you have the same thing like that at the time of on. But at time of off, nothing. So it goes off like that. Okay, did you get that? So that it can repeat again like that. All right, so, but what will be this peak value? It will be the same as this peak value, right? And the same thing here, the minimum value of that is the same thing as what is happening here. So what is this? In other words, what is that? So if you know, first of all, this value, I in, will have, I average through here. All right, what is flowing through here is I in divided by the duty cycle. So if you know that, right? Now that means from here to here is I in over K. So if I want to get from here to there, I need to add from here to here plus from here to here. But from here to here is this delta I divided by 2. So this small part is delta I over 2. So I can write here now that the maximum value at this point, let's say at that point, I max will be I in over K plus delta I over 2. Okay, the same thing with this transistor. The maximum value here of the transistor is the same thing as I in over K plus delta I over 2. If you want to get the minimum value here, all right, which is this point, okay, which is that point, to get that minimum value, you just say from here to here minus this delta I over 2. So this minimum value will be I in over K minus delta I over 2. The same thing here. Okay, here is I in over K minus delta I over 2. All right? Now let's look at what happens to the diode, the current through the diode here. All right, remember at time of on, there is nothing flowing through the diode. So you get 0. All right, at time of on, nothing is flowing through the diode, so you have nothing. Because here there's nothing, but here at time of off, immediately you switch this off, current flows like that. So in other words, if I have my diode there, the same current that is flowing through here, okay, is what flows through the diode. So if I know how much current is flowing through the inductor, which is this one. You can see here, look at it, this is what is flowing through the inductor at time of off. So I'm just going to duplicate the same thing there. So I have that flowing at time of off. All right. So you have like that. So just a duplicate of that. All right, for that inductor. Okay. So that the peak value here is a peak value there. The minimum value here is also a minimum value there. Now, what about the capacitor? The current flowing through this capacitor. Let's check what happens at time of on. When you switch this on, right, now current flows through here. Whatsoever that is here, if the current is flowing like that, it means that this IC, all right, is the same as minus IO. All right, IC is minus IO. So that when you say IC plus minus IO, we give you 0. All right. So in that case, once this is on, IC is minus IO. So now here, IC, I'm going to have minus IO there. All right, at time of on. But immediately you switch it off, which is here. Now this current will flow this way. Some will go to the load, some will go to the capacitor. Now I want this IC. All right. So remember that this current is discharging, right? So as it's discharging, discharges through the capacitor and also through the load. Normally you have, how much current do you have here discharging? Look at it. This is what is discharging. So you are going to have what is discharging, okay, like that. Okay, so it discharges. So you are going to have a duplicate of this here, but now that duplicate, that your I diode duplicate is divided into 2. So in other words, if I want to get what is going through here, the current, I need to remove IO. So in other words, this peak value here, all right, will be the same thing as a peak value there that I have, but minus IO. All right. So it will be I in the same peak value that I have here. I in max, this I max minus IO. So in other words, it's the same thing as saying I in over K plus delta I over 2 minus IO. And also here will be, this will be I minimum minus IO. Okay? Which is the same as saying I in over K minus delta I over 2 minus IO. All right, so you get that. Did you get it? That is the current flowing through the capacitor. So it's negative and then negative IO, and at time of off, that switched off, you get that. All right. Now the next thing again that we look at is the voltage, the output voltage. All right, VO. So let's see what happens to the voltage. Now, when this is on, let's see what is going on here. Whatever that is here is being discharged to that, right, to the load. Did you get it? So the voltage reduces. So the voltage will reduce like that. And then when you come to this point, when this is now flowing, what is happening to the voltage? The voltage builds up, right? So we have voltage builds up. So you get like that, going up, up, down. So you can have also the average value of that. But between this point and that point is your ripple voltage, delta V, right? So, and this is your average voltage, V average, VO average. Okay, so this is the waveform. You should know this waveform very well.